Okay, guys, for this one, the title says the difference of two squares. And I need you to understand that this is one of those terms, those names that you need to remember. It's something that you're going to see throughout your high school math. The difference of two squares. Okay? So I'm going to underline this, or I'm going to circle it, or whatever. You should do the same. You need to remember this term, the difference of two squares. I'm going to show you what we're talking about in just a moment, but you're going to see it a zillion times. You're going to need to multiply them, and you're going to need to factor them. Right now, you're not seeing what the difference of two squares looks like. We need to multiply these things, and then our answer will be the difference of two squares. Well, let me show you. You guys may have already started. But what we're going to do here, it says write each product as a binomial. What do I normally write? What do we normally get when we multiply these two things, Jordan? A trinomial. But it says write each product as a binomial. That's interesting. Let's see what happens. Notice that the front numbers for both are the same, x and x. The back numbers are exactly the same, except their signs are different. One's positive and one's negative. So let's see what happens when we multiply this out. Okay? All right. X times x gives me x squared. X times minus 3 gives me minus 3x. 3 times x gives me plus 3x. There goes that middle term. That's why it's not going to be a trinomial, because they're going to cancel out. Let's go ahead and finish. 3 times minus 3 is negative 9. Now I want to combine like terms. Negative 3x and positive 3x go away, and I get x squared minus 9. Guys, I want you to notice something. This is 1x squared, right? Do you agree that this is a perfect square? 1 times 1 is 1. X times x is x squared. Do you see that this number, just the number itself, not right here, but just this number, 9, you agree 9 is a perfect square. It's 3 times 3, right? And what is that sign? What's the word that means that sign? You might have it? I mean, this thing right here in front of the 9. What does it read? It's a difference. It's the subtraction sign, and subtraction is a difference, right? This is the difference of two squares. The difference of two squares. Remember it. Remember it. You need to remember it. Let's look at this next one. Okay? 2n times 2n is 4n squared. 2n times minus 5 is minus 10n. 5 times 2n is positive 10n. 5 times negative 5 is negative 25. I combine like terms, negative 10n and positive 10n, they just go away. And I get 4n squared minus 25. Guys, you need to see this. You need to be able to look at it and understand it without me identifying it for you. I'm not going to walk by your paper and go, hey, this is the difference of two squares. You need to look at it and go, oh, this is the difference of two squares. Like if a zebra walked by, you'd go, oh, that's a zebra. Okay? You need to know the name for it. You need to recognize it. You need to see it and name it, because it means something. And we'll get to that in just a minute. We can memorize this pattern. We know what it looks like factored. Right? I can go back, and I'll show you that in just a moment. But does everybody see how these two things get multiplied? This is the difference of two squares. Do you agree 4 is a perfect square? It's 2 times 2. You agree n squared is a perfect square? Yes, it's n times n. Do you agree that 25 is a perfect square? 5 times 5. Okay, it's the difference of these two squares. All right, excellent. Let's look at the next one.